Greetings, everyone, and thank you for attending our webcast today. My name is LIFECYCLE, and I'll be your moderator. I'd like to welcome you to today's webcast entitled Barriers to Container Security and How to Overcome Them. This event is brought to you today by funnelside.com and is sponsored by WhiteSource. Well, over the past few years, more companies have been turning to containerized environments to scale their applications. However, keeping containers secure throughout the development lifecycle presents many challenges to security and development teams. In order to address those challenges, organizations need to adopt a new set of security processes and tools. Today's webcast will focus on three of the most vulnerable areas of container security and best practices to help teams develop and deploy them securely. Our expert speaker from WhiteSource will be discussing the top challenges to security in containerized environments, how DevSecOps can address security in containerized environments, and tips and tricks for successfully incorporating security into the container lifecycle. Our featured speaker today is Jeffrey Martin. Jeffrey is the Senior Director for Products at WhiteSource. Well, thank you all again for joining us today. Before I get started, I just have a few housekeeping items to cover. First of all, if you would like to enlarge the slide view during the presentation, just look for the square icon in the top right corner of the slide window. You can also view the presentation in full screen mode if you like by clicking on the squared arrows icon. If you would like to submit a question at any time, which we strongly encourage you to do, just look for the question field below, to the left of the slide window. Type your question in there and hit submit, and we'll get to as many of those as we can at the end of the presentation. If you have any technical difficulties during the session, just look for the yellow question mark icon below the slide window. Click there and someone will be able to help you out. If you would like to download a copy of the presentation you're about to see, just look for the Resource Center just below the question field. Also want to let you know this webcast is indeed being recorded. You'll be able to access the recording within a couple of days using the same link you used today. You can then listen to the webcast again or pass it along to share with a colleague. And also, to thank you for listening in today, we'll be giving away a $100 Amazon gift card to one attendee listening in to today's live broadcast. We'll pull that name after the webcast, and we'll be in touch with the winner shortly. Now, without further ado, I'd like to hand things over to Jeffrey Martin. Take it away, Jeffrey.
Hi, thanks. So my name's Jeff Martin. I'm the Senior Director of Products at WhiteSource. And if you're not familiar with WhiteSource, what we do is open source management, both vulnerability, license information, and inventory. But today, focusing on the security piece of this, and just to get us started, I will be laying a little bit of a groundwork. Groundwork, that is not the right word. Baseline, making sure we're all working from the same point of knowledge before I really start diving into the actual specific barriers. I've identified 4 I want to focus on, and we'll go through what they are and how those barriers get to be overcome. But first, let's set that baseline. Okay, so I'm starting really basic here. Fundamentally, container lifecycle contains 3 pieces, 3 phases: building, shipping, and then the actual running of the container. I'm going to talk about each of these phases a little bit separately, but just to kind of start us off, fundamentally, each phase has its own security challenges, and security does not belong to any one of these phases. You don't only worry about security when you're shipping or when you're running or when you're building. Realistically, security is an ongoing process that needs to go through and be checked in every one of these phases. So we all understand, I think, the build phase and shipping and running, hopefully. But I do want to take a quick second and just talk about the structure of a container. Now, there's many layers in the container. This is just one way of addressing those different layers. But the actual writable portion, which is where most people focus on security, is only a relatively small percentage of the actual container itself. And vulnerabilities do not exist just inside that writable portion. Many vulnerabilities sit there and live inside, let's say, Debian. But your base image is where the base of security really starts. It's important to not just focus on any one of these pieces or to ignore pieces. Very often what I find is people say, I only want to care about what's in the writable area. The base image, that's another team. And as I kind of cover it a little bit later, we do have to kind of break out of thinking of this in separate teams. Containers is one of the few areas of technology where we haven't really started breaking down those walls. We've all talked about DevOps, DevSecOps for years now. Agile started trying to break down the barriers between teams. But DevOps is the easiest example, right? Breaking down the team between who owns the development of the product and the delivery of the product, if you will. And making sure that we're all working on the same team, not just saying that that's somebody else's problem. But with containers, because it is a new technology, relatively speaking, I still see a lot of people say, nope, base image is a different team. I only care about what I'm writing on. That's a whole separate set of problems. They have to solve that. The way we have approached development holds true for containers just as much as it did for DevOps and just as much as it did way back in the day when we started going agile. So long story short, we do have to think like we're all on the same team and that we're all pulling towards the same goal. There we go. Literally misclicked there. Here we go. So there's some obvious base level questions with securities before I start going into the real vulnerabilities. This is just the basic general hygiene you need to execute. Very, very simply, private registries are a very good idea, right? Making sure everything is kept inside. But if you're using a public registry, you also need to make sure things are signed. And there's basic pieces like making sure that anytime you're running a container, you're not sitting there using a root user, right? This is all the basic security principles, principle of least access, etc. One thing that is very important is the concept of using a registry. Allowing developers to pull in containers from just anywhere is a recipe for causing yourself more challenges with security than you really need to. This holds true and is something we're used to from just good old-fashioned packages and libraries and other components. Registries help maintain control. So container registries are very, very skilled, and there's always a new one coming out, it seems like, but it is a solved problem of having container registries. My personal favorite is the new GitHub one. I hear Amazon, AWS is about to come out with another one. But fundamentally, storing containers in a registry, essentially whitelisting which containers are available for use by your developers, is a solid, good baseline practice, separate from even security, as that also helps with things like quality and just simply knowing what it is you're using. But let me switch over to my specialty here, vulnerabilities. So why do we care about vulnerabilities in containers? Well, it's because containers especially, even more than regular software, just simply any code always uses open source, but in the container space, we tend to use more. Remember, I'm not just talking about the writable layer. Your base image contains a ton of open source components. And fundamentally, open source has a different security vulnerability problem than proprietary code or even third party, a commercial third party. The main reason is we are reporting more and more open source security vulnerabilities every day. It's open, so the problems are public, which means if I am a bad actor, that is the first place I'm going to look. A list of public vulnerabilities that I can use to do whatever bad thing I'm trying to do. Right? The fact that open source is open is a huge plus in very many ways. But it does mean that the problems are also public. So what that ends up looking like, and this is just a sample of a few different CVEs, is that you basically don't have a heck of a lot of time to actually fix an open source problem. Because the second it's published, if you're on that out-of-date version, bad actors are already trying to use it. So while we have more so we basically have more vulnerabilities. It's increasing. The 2019 numbers haven't really come out officially yet. I expect it to be much higher than 2018. But we have increasing vulnerabilities. You have an increasing amount of bad actors, and you have very, very little time to remediate these vulnerabilities before you're moving on, before you actually have that attack window open up. So, and by the way, I should mention, love questions. I saw a couple just coming in. Please keep them coming, because if I can, I'll actually address them as we go when they fit. So I did just get a question from Rajesh. I promise, actually, I'm going to cover that in a second, so hang on. So fundamentally, like I said, more vulnerabilities, less time to fix before they're actually exploited. And I just wanted to kind of reinforce this with just a few stories from actually last year mostly, with essentially really, really big bugs that snuck into almost all containers, right? Kubernetes bugs affect everybody who uses Kubernetes, which is 90% of everybody who deploys containers. Those were not in writable layers. Those are in your base layers. So there's a lot of concerns with container security as a whole. But when it comes to the open source vulnerabilities, the biggest surface area, the attack surface, is in your base images. And that was just a few proof points to say, hey, this is really common and unfortunately public as soon as it happens. Now, I'll take a quick second and talk about update hygiene here, just because I don't later on. But it is always a good idea to make sure that all of your components inside your base image are as up to date as possible. Now, there's a lot of technologies out there to keep up with that. But fundamentally, you do have to balance that with the ability to retest and actually make sure you're not going to break anything just by updating, some Kubernetes file. Keeping things up to date is hard, and I'll go through some ways to handle that in a minute. But I see too many people come to us, and we see their software, they're asking for advice, and what we see is large amounts of things that are 6, 8, 10 months out of date. It doesn't take that long to, what's the most recent one on this one? February of last year. You don't have to be all that out of date to still have that vulnerability open inside your base image. Okay, so I've talked a little bit about some of the problems, that it's an increasing piece. I do want to take a moment before I get into my 4 big barriers to talk about some methodology, and I'll bring it right back to this. And again, I'm going to set a little bit of a baseline. I hope you all have heard of the word DevOps and DevSecOps, but this is still something that's an ongoing transformation in our industry. I talked to many, 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 many companies, and I would say relatively few of them have really fully embraced the idea of including security inside both their dev and ops. They still think of security as a separate gate after development. This is both inefficient and even more important than the inefficiency, because frankly only the number counters care about that, but even more important than the inefficiency, it's actually not a very good way to remediate and fix problems. It leaves too big of a gap. If you're doing full DevOps and then security is running only on the deployment phase, let's say, you have this huge gap where you're continuing to develop. Your security team is always behind the ball, and the remediation is always slowing down deployments. There's a lot of ways to handle that, but fundamentally the baseline method here is to include security concerns in every single development phase. that means security becomes everybody's responsibility. It sounds like a cliche, a bumper sticker for a particularly developer-heavy car, but security really does need to be part of what everybody cares about. And just to be nice and thorough, what I mean when I say every phase of the SDLC is literally everything from before you code, through coding, building, deployment, and maintenance, of course. But the part where we're not doing a great job is the part in the two blue circles here, right? Planning, which I'll cover, and coding. Planning starts from picking your components. It's a common practice to bring in components without checking to see if they are the most up-to-date versions or if they have any known vulnerabilities open. This is something that this is where I'm start talking about bringing security into the developer part of DevOps. Before a line of code is written, or perhaps right as the line of code is written, it needs to be part of the practice to include a check to make sure you're not bringing in out-of-date libraries and including them in your base images or in your writable layers that are already out of date. Because what happens then is you're basically guaranteeing a remediation cycle, right? You're bringing in something out of date, or with, maybe it's got a known critical vulnerability and you don't even check. You're putting it into your code. You're building out your code, building a container out of it, scanning a container, finding the vulnerability, and then going all the way back down the chain to actually identify the right piece, tell the right developer to update the right library. Fundamentally, it is a much better practice to make sure you know that everything you're putting in is good before you put it in there. Again, sounds almost cliche and it sounds simple, but it's a practice that has not been widely adopted. And that's sort of my line there between planning and coding, right? When you're selecting components to put into things. Now, coding, just to separate off that phase for a second, includes a lot of different activities, right? We talk a lot about CI/CD, continuous integration, etc. But again, there are checkpoints during your pipelines, the part where coding starts turning into building, where you are almost negligent if you aren't including security scans in there. Why? Because again, it's just less expensive and easier to remediate problems earlier in the cycle before they go through many, many steps. And then, of course, there's the actual build and deployment, especially of your containers, right? Because as you actually build out your containers, you want to include yet another check, making sure that you are not introducing vulnerabilities that you can prevent and you therefore don't have to remediate. And the reason this is so important, just because I love throwing numbers at things, is that it becomes exponentially less efficient to fix. In this case, I'm calling it a defect because in a way it is. But fundamentally, a security vulnerability is just a kind of defect. There is a huge cost to catching something late. You're involving more people, more systems, more tooling, and you have to do more once you remediate it. That whole cycle starts again instead of only going back one step. So there's some industry standard numbers here that apply to security vulnerabilities the same way they do to quality, quality defects. It's much, much less expensive to remediate something at the beginning or prevent it from going in the first place. And this is all fundamentals. This is not something specific to security for containers, but it's a piece that as an industry we keep sort of forgetting that containers are not a separate thing. They are part of this pipeline just the same way everything else is. So I've talked a lot about putting in some gates and different changes, and actually my next slide actually covers the barriers. But I do want to give you guys some context into what we've seen in our own client base. because this is something we help people with, we gather information about it. And realistically, right now, the industry as we see it, people spend the most amount of their time implementing security measures pretty much evenly across the three phases, if I kind of break it into just pre-build, build, and post-build. Now, this is not the most efficient way to do it. This is simply measuring where they spend their time. The fact of the matter is it takes less time to catch things before the build than it does post-build. So when I see somebody who's spending more of their time implementing application testing for security before they're built, they are actually saving themselves a considerable amount of time. If you're spending most of your time remediating security post-build, you're doing it a little bit inefficiently. Okay, so now to the good stuff, the barriers. I've broken it out into 4 big barriers and then gave them a single name just to try to help out here. So the barriers are pretty much maintaining control of your containers, making sure you know what's going into your containers, your sources. You do have a hygiene issue here, which is just making sure that you're following some base level practices. I would not have normally included that into barriers. If I was brand new to the industry, I wouldn't have necessarily thought hygiene in general was a problem. However, just from what we see in the world, it's still a very, very large problem. People don't always have the best hygiene practices. And then there's actually the last piece here, the biggest barrier in most people's heads if they haven't really thought about all of this, which is the deployment piece, right? Making sure that you're deploying correctly. So I'll start with maintaining control. So there's a few different pieces of controls that is very, very fundamental. The idea of controlling what goes into your containers and what happens to your containers and which containers other developers are allowed to use is fundamental to the idea of security. Now, somebody in the Q&A actually had asked, is making containers read-only and attaching a volume or config maps a good idea? Read-only goes straight to control. Principle of least access pretty much states that any container that you have, or realistically anything that has to be secure, you should give people the least amount of access to it that they can possibly have. Read-only is an excellent idea once everything is built for the people who only need read-only access. And that sounds like a little trite almost, but it's just a true statement. This is the same as good old-fashioned security or network security principles, right? You don't give people write unless they actually need the ability to write to accomplish the job you want them to accomplish. That has a huge impact, actually, when I start talking about container registries. I included the development and build phases here for completeness, but realistically, I've talked most already about the control there. During the development phase, you should make sure, and there are many tools to do this, to ensure that people are not including things that are already out of date or already have security vulnerabilities. You don't need to start behind the ball. This doesn't even necessarily require advanced tooling. It could simply be really encouraging your developers to check. It is not hard to look at a repo and make sure that you are pulling in the most recent version. It is simultaneously not exactly hard anymore to go and make sure that your vulnerability, that it has no known vulnerabilities. There's very little reason nowadays to pull in old versions of things. Again, unless there's a functional compatibility issue, in which case you do have to actually consider how that works across your different dependencies. During the build phase, this is your traditional CI/CD. Gates are a way of control. Any reasonably modern DevOps pipeline should include gates for security as things are built. Those gates can be numerous. There's a lot of different ways to do this. Obviously, I'm biased towards our own tool where we live inside the CID pipeline and actually just let you run a scan. We go through all your libraries, whether they're in a container or not, and actually tell you, do you have anything out of date? Do you have anything that has a vulnerability? But the idea of instituting gates maintains control to make sure that as you move to the next phases, you are not keeping problems there that you're going to have a more expensive time remediating. But I do want to dive in deeper under the container registry concept, because I think this is an underused pillar, if you will, of security. This does not have to go so far as to say you have a registry and it's a whitelist and developers can only use containers in that registry. What it can go towards is a registry of items that you know are at least secure to your policies. There are other concerns here, maintaining the container registry, ensuring that everything you actually need is in the registry. The second you try to institute a whitelist, people always find some reason they have to go outside the registry. But fundamentally, a registry, a store of containers known to be good in quotes to your definition of good, is fundamental to the idea of where container maintenance and security is going. Then, of course, there's the deployment phase, which I think I already have a few questions on here. But realistically, container registries are a very, very good practice to maintain control and ensure that you know what is being used. If you do not know what is being used, you cannot secure it. Okay, just to kind of hammer on that point of if you don't know what's in there, you don't know how to secure it. Sources. Where you put the items into your registry. Fundamentally, you need to trust what you're bringing in. That means there should be an additional gate, especially if you're bringing in containers from a public registry, that enables an understanding of the security of this. You can trust a source, right? Great. It's, Debian. Perfect. I trust Debian. But you still need to verify. Fundamental, again, to security. Trust but verify, right? Everything you bring in should be scanned. A container registry allows you for that point where you can say, great, before we put it into the registry, we are going to scan this, and we are going to understand what vulnerabilities exist in it. You might not have a policy that says you need to have everything remediated, right? Maybe it's not a zero vulnerability policy, but you do need to know what's coming in. You do need to approve it or not approve it. It's another kind of a gate. This source could, however, also be internal, right? Different teams work on different pieces of large products. That's fine. And every team might be following the same process. But before you actually put it into your actual code, you should verify that the other team has done their job. Some of what this looks like is, of course, just simply running security checks. Other pieces, however, are if you are bringing something in from a public registry, make sure you sign it. Or make sure it's signed, because there is an opportunity to insert in here, right? You do have this fundamental problem of bringing something in from the outside. You need to verify it is what it says it is. All right. Hygiene. I always feel like I'm about to talk about, showering here, but hygiene is a piece of security that is extremely important. So when I start talking about hygiene, I'm going back to some of the really basics for security. And I know this part actually sounds incredibly basic, but it's really amazing how many people aren't doing these basics. And if you are, and you're like, yeah, Jeff, I already do this. Great, pat yourself on the back. You're, one of the 10%, top 10%. But I guarantee you other colleagues in the industry aren't doing some of this. The amount of times you see in orchestration, so good old Kubernetes, right, where we aren't enabling just basic role-based access control, right? Goes right back to that question about read-only. Yes, the default should be read-only unless the purpose has to have write. Too often, we see everything defaulted. Basically everybody's got full permissions. This is not a good practice. Very, very, very often, I will see people put in role-based access control for what I'll call users, subjects, right? But they'll leave the API part wide open. Fundamentally, this isn't anything revolutionary, but it's important to remember to apply the basics to containers. Containers is not a get-out-of-jail-free card to, avoid your basic security hygiene. But a more specific piece here, namespaces. Again, people are not putting up boundaries appropriately. And this is another basic concept, right? You need to fence things off. You need to create namespaces to create these security boundaries. Very, very often, even in big products, you'll see things deployed that because they're a container, these practices tend to be avoided or ignored. And I think it comes from a place of when containers first popped up years ago, it was almost a specialization. And people created exceptions to their base level security policies and their base process. They treated containers as something different. And if you take nothing else away from this webinar, fundamentally, containers are not different. They are code. They contain a higher percentage of open source than normal code, which is already at 70 to 80% open source. And the same base practices of security that we've practiced for decades apply to containers just as much as they apply to everything else. So, to kind of sum up here on the deployment phase, because that's where most people actually focus. Unfortunately, there's a practice of allowing containers to go through their own process and then only worrying about security on deployment. This is still an important phase, even if you are practicing the best container security, treating it like every other piece of code, including it in making sure you're not including things that are already automatically out of date, making sure you have control, so you're instituting gates to actually check along the way to make sure you're catching any vulnerabilities while they're still efficient to remediate. Even if you do all of that, well, you still have to deploy it, and that's still another spot to check. But deployment does have its own unique challenges and its unique pieces. Fundamentally, and the first part, which I hope everybody's already doing, is you shouldn't deploy images with known vulnerabilities. Images need to be scanned. They need to have their components identified across all layers. And this is important. You need to know what's in there across every layer. Once you have that inventory, that bill of materials, you do need to double check that across an actual list of known vulnerabilities. There's many ways to do this. Tooling is the most automatic, easiest, and fundamentally the right way to do it. But it is very important not to just focus on preventing deployment of images with known vulnerabilities in the writable layer. That base layer, as I showed you, a few slides ago with the kind of news stories, the base layer is still where a large chunk of open source and therefore a large chunk of your vulnerabilities live. All right, so that's the basic, right? You're going to prevent deployment of images with known vulnerabilities. We don't need to start off bad. You do, however, also want to validate the image signatures, right? You want to double check. And that's pretty straightforward. But monitoring for new vulnerabilities, and this is a very important piece. You need to not just go, great, we've deployed this, and now we know that it's safe, and therefore it's safe forever. In an ideal world, you're deploying in a continuous delivery fashion, and you're constantly running these checks, which is great, but it is not sufficient. Because realistically, when you're putting things out in the real world, a lot of times they kind of sit there for a while. Even in an agile process, even in continuous delivery, containers have a tendency to sit, especially with the base layers already intact. Realistically, you do need to have something that holds your inventory and checks for new vulnerabilities against that inventory. Again, ideally, you're constantly changing things, and you're catching all of this throughout your pipeline, and it's great. But we all know that ideal world doesn't really exist. There's always those deployments where, it's not a SaaS operation. You're deploying to on-premise, and you're handing it out to customers. Or it is a SaaS instance, but you have a legacy section so that it's, long-term support. Fundamentally, there's a lot of containers that sit. Those cannot be ignored. Those are the areas where, because you're making the assumption that it's already secure, you stop looking, and that's when people come in. Realistically, what this looks like is a tool. You need to have some sort of tooling to hold your inventory and double check it against new vulnerabilities that pop up. If I go all the way back to my very first slides, what you'll see is that I was talking about the known vulnerabilities increasing, frankly, exponentially. It's almost an incredible chart. Because of that, it is almost impossible to keep up with. So you do need some sort of automated tooling to make sure that when new vulnerabilities pop up, that's applied to your containers. So with that said, I've kind of gone through the entire pipeline. I went back, and I'm actually going to do something I never do, go back a slide, just to talk for a second about control, source, hygiene, and deploying, right? Those are the four biggest barriers. And if I had to, somebody forced me to say, what is the one single biggest barrier to keeping your containers secure? The number one, the part where I think most people are just sort of falling down, is knowing what you're putting into your containers and making sure you're actually remediating vulnerabilities as early as possible. So I know I've got a bunch of questions coming in here. So I do think I answered the one about the volume, but let me make sure that we catch them all. So we'll go to the Q&A phase. So just to kind of quickly recap, you can type in anything you'd like in the Q&A piece. I do try to end these a little bit earlier, give you a little bit of time back to your day. But we'll definitely spend around 10 minutes here going through some questions. So type them in if you got them.
All right. Yeah, thank you very much, Jeffrey. You've covered some great stuff there. I like the way you segment that into those vulnerabilities. And certainly monitoring for new vulnerabilities. I mean, as you well know, the threat landscape is always changing. It's always growing. And I just want to remind everyone listening in that there is still time to type in a question if you'd like. Just look for that question field to the left of the slide window. Type your question in there and hit submit, and we will get to as many as we can. And also if you wanted to download a copy of the presentation you just saw, just look for the Resource Center below the question field. All right. You did address that question kind of during the course of your presentation there from Rajesh. Did you have anything else you wanted to add to that about making containers read-only or attaching a volume or config maps?
So actually, I didn't actually talk too much about config maps there.
Okay.
So fundamentally, volume and config maps are a good idea. There's a reason they exist. Yep. I read the question. I was almost like, yep. I could have just typed that in there. Yes, making containers read-only and attaching a volume or config map is a very good idea. It is a fundamental base security practice. I didn't cover it in the hygiene. I probably should have. But the fact that the question needs to be asked, I think, hammers home my point. Containers are not fundamentally that different from everything else you have to secure. It's a group of code. And the more people think of containers as something separate, the more it becomes a challenge to actually handle security correctly.
Yeah, that makes sense. All right. We've got a fairly basic question here, and I think I know how you're going to feel about this. When it comes to effective container security, do these security protocols need to be baked in at the start, or can they be effectively added in later on?
No, just add them on way after you deploy. That's fine.
Tap on like Post-it notes.
Yeah, that's absolutely, that's great. Just tack it on later. I mean, look, not every security protocol, if you will, should exist at every phase, right? There's some things that aren't applicable. But for the most part, most of your security protocols are there for a reason, and they should be applied as a gate at every phase. You shouldn't be able to check something into a container registry without it having gone through several checks already for vulnerabilities. And I think I kind of hammered that home probably a lot. But fundamentally, you have to bake it in as early as you possibly can, actually. So not just at the start, but before the start if you can.
Right. So before the start and then kind of at every phase, it sounds like.
Yeah, and that's the part where a lot of times when we get down to implementation, there becomes culture issues, right? My team doesn't have any say about the pipelines that the builds go through. Fine. I get it. You can't, in the real world, always implement your security protocols the exact way they should be implemented in every environment through every team for just practical reasons. But it should be the goal. And if you have to make an exception, you have to make exceptions. I have run across people who, security team can't control the DevOps pipeline. Sounds insane, but I just talked to a customer this morning like that. Great. Fortunately, they were using a container registry, so they were going to run a check after the pipeline before it goes into the registry. And they were able to basically create a rule that you can't pull in containers except from the registry. So they're able to kind of mitigate that. But realistically, the right way to do it is to do that and do it during the pipeline build.
Right. That makes sense. For sure. All right. You're talking about thinking of containers as just a bit of code and not thinking of them as separate things. Why do containers have these unique security requirements? Aren't they similar to a virtualized environment? Is that
Somewhat.
not the right way to think about it?
Somewhat. And the reason is because they, as much as I say, think of them like any other piece of code, that's more from a practices standpoint. Practically, they are a slightly different thing. They are their own contained environment. When I say treat them like any other code, I am almost purposely ignoring what makes containers unique and useful. Because from a security perspective, the usage isn't necessarily the most vulnerable piece. Containers are similar to a virtualized environment in that they are a self-contained environment that is deployed in a very similar manner to how environments, good old VMs used to be deployed. They're not consumed quite the same way, but they are similar to a virtual environment. But it's a virtual environment made up entirely of code with pieces that are built from your normal pipelines in most cases. And that makes them a unique challenge because you do have to treat them like an environment you need to secure, but you also need to treat them as code. And I think as an industry, we focus so much on treating them like an environment, we sort of forget the fact that they're just built code.
There's portions of code that comprise them.
Right, and it's funny because for me it's both. Right, but I purposely tried to focus a little bit on more on the code side of it because I think most people, when you talk about container security, they think about after deployment, securing it, treating it basically like network security almost, and that's the current state of play. But people do need to start thinking of it about how we build it, how we include what items in it, and making sure we know what's in there. Too often it does fall into like the VM type piece where you don't even know everything is in there. People are so used to thinking of it like a VM. I was trying to push them the other way.
Yep. All right. Well, let me know before this next question. Let me just jump back to one of your earlier slides, talking about the software development lifecycle here: planning, coding, building, deploying, and maintaining. Now, the question is, do security requirements for containers change throughout this lifecycle? If so, how and why are they changing?
Oh, sorry for the silence there. I gesticulate when I talk, and I think I hit mute.
That's quite all right.
So, the SDLC and how it's changing, especially in the past couple of years, is an interesting topic kind of by itself, right?
Yeah.
Because, and I'll give you my kind of personal view on this, not so much speaking for WhiteSource right now, but more for me, is that for the past decade or so, what we've considered the SDLC is collapsing. And what I mean by collapsing is it's becoming more condensed. The roles are actually combining. And we're not treating it the same way as that old waterfall almost model of your SDLC, right?
Sure.
If you look at Agile and then DevOps, and now we're talking DevSecOps, and I've heard people use the word DevQAOps, what we're really describing is that the roles are becoming more automated. There are concerns that skilled people need to be concerned about all of these things, QA, security, et cetera. And just kind of fundamentally, we're trying to build these delivery pipelines that are not as gated in terms of time. If you flash forward another 5 to 10 years, I think the current SDLC model will almost seem quaint, because most of it will be automated, and it'll be a conceptual model like how we teach our kids what the solar system looks like, with like those little circles, even though they're all ellipses, or the model of the atom where we have actual circles instead they're actually like clouds. It's going to look like a simplified model of reality, where there's not this clean division between deployment and build. And that's what we've been collapsing for the past few years, and it's why I think containers especially is an important piece, because we've almost let them go on to the side as a separate process, and that will come back and collapse into their base level SDLC.
Yep. Okay, that makes sense. Is it possible to, like, when looking at containers and container security, is it possible to apply some of the more, quote, traditional security and access control methods like multi-factor authentication? Can you bring those sort of things to bear on containers? Absolutely.
The problem is, of course, where it's being used. So much of that level of security is really dependent on how and who is using that. Multi-factor authentication is a great practice, actually, if you're having somebody come in from externally. But you're not necessarily going to need all that if you just have some container that's used for deployment or testing. Very often you see testing containers.
Yep.
So fundamentally, there's other base level practices there. And I covered a couple of them, right? Like least access. Principle of least access, right?
Role-based access control and things like that.
Right.
Yeah.
Multi-factor is really just an authentication method. Your authentication method should depend on the usage, but have an authentication method. Period. And that's, it sounds sad, but that's actually, I think, where most people are, failing, right? Where they're not even putting any authentication in, never mind more advanced authentication methods.
Yeah. God, it seems crazy to me that people would leave the door wide open like that, but,
It's funny, containers fell into this odd space of people just being like, that's something different.
Yeah.
And we do maybe scare them on deployment, but...
Okay. All right. We got one more question here, and then we can wrap up. This is a little repetitive, but, it might give you an opportunity to kind of give some closing thoughts here. Why should it be more challenging to ensure sufficient security for things like containers?
I mean, if I'm going to break the challenges down, I guess I like my lists.
Yeah.
If I'm going to break the challenges down, you've got a culture problem. There's a technology problem, just fundamentally, and there is what I'm just going to call a mindset issue.
Yeah.
And this will kind of give you my sum up, I guess. The culture problem is we treat it like something different.
Yep.
We give them that exception. We let separate teams worry about containers instead of the the full development team. We don't include them. We don't think of them like other pieces of code. To me, a container isn't fundamentally different from a usage perspective by a developer than, let's say, a very common package, right?
Uh-huh.
So that culture issue becomes a big challenge. Bringing that into your normal DevSecOps process helps solve that problem. But there's always organizational challenges and culture issues there as well.
Sure.
Your second layer is the tech, which is fundamentally you have to treat this like both code and an environment, like I said. So it's an environment to secure, but it is also a bunch of code that needs to be secured.
Yep.
And that technology change means you're going to have to apply the rules essentially for both. You have to treat it like an environment, and that should follow all of your rules that you have there, right? Access control, authentication methods, right? You have to treat it like an environment.
Yep.
But what, again, most people aren't doing is treating it like a bunch of code. Yep. They do things like ignore base images, or the common layers.
Yeah.
And then that last one is that mindset shift. Containers aren't new anymore. They are not their own weird specialty. They're a fundamental piece of development. People still think of them differently. And look, I get it. 5 years ago, I don't think anybody was really talking containers, right? We were talking VMs. Yeah. But, it's new-ish. But at the pace development and technology changes, this is now established. This is a base level. Everybody's using them, and we need to absorb them into the actual culture as just another thing, like we did with packages originally a long time ago.
Yeah, that makes sense. So it's not like a new set of rules. It's sort of just combining existing sets of rules.
Yep, it's a new application of the rules that we've all followed. Security actually isn't that hard. Yeah. Fundamentally, we know what the principles are. It's only hard in execution, not in concept. Yeah. And the execution for containers is actually easier than a lot because everything's already basically code. It's a lot easier to secure a container than a standard traditional VM. But realistically, we do have to acknowledge that the base level rules still need to be applied, and we do need to treat it kind of as such. We can't create exceptions for containers.
Yep. That's a good way to think of it. I like that. All right. Okay. Well, those are all the questions we have, and that's getting near to be all the time we have for today. I would like to give a huge thanks to Jeffrey Martin for a very informative session. Covered some great stuff here. And I'd also like to thank WhiteSource for sponsoring this webcast. And I want to remind those of you in the audience that we will be giving away 2 $50 Amazon gift cards. I misspoke earlier and said $100 card. Giving away 2 $50 Amazon gift cards to 2 attendees listening in today. If it is you, we'll be in touch shortly. Also want to let you know within the next day or two, you'll be able to access an archive version of this webcast so you can review it again or pass it along to share with a colleague. Just use the same link with which you logged on today. Well, thank you very much for attending, and this concludes today's webcast.